if we think of the number 5 plus 5 plus 5 plus 5, so mathematicians needed a way to write that in shorthand, particularly if you had more than 4 5s, you had a lot more than that. But this can be written as 4 times 5. So a short way of adding up, or another way of adding up 4 numbers, is just to multiply that number, if it's the same number, by 4. If we had 5 times 5 times 5 times 5, we needed to invent some way of writing that in shorthand. So we can't say 4 times 5 there, because that's not 4 5s are 20. This is going to be much bigger than 20. So we're going to have to come up with another way, and we write the number down that is repeated, and then we count the number of factors, and we put that up there as what is called an index or a power. This number down here is what we call the base. So it's a base that's raised to a power, and it's only if that number is multiplied repetitively. So if we've got a number, say 2 times 3 to the power of 6, what we do is, using BIDMAS, there are no brackets, there is an index though, so we do the index first. So we actually just raise 3 to the power of 6, and what's that, 9 cubed, 729, so it'll be 2 times 729, and that's what, 1458. So don't think that 6 power there applies to the 2 as well. The 6 only applies to the base, not to the number that's at the front. Okay, so we've got indexes and powers, and there are some rules that govern how we coped with these indexes and powers. So we'll call them the index laws. They are laws that need to be committed to memory, and once you get the hang of them, they should fall into place for you. So the first one is multiplication. And we're going to use some algebra here so that it applies to all scenarios. So if we've got a to the n times a to the m, now a, n and m are integers. Well, let's just say no, they are real numbers. Don't have to be integers. A, n and m are real numbers, so a to the n times a to the m equals a to the n plus m. So let's just do an example out here. 2 to the power of 3 times 2 to the power of 4 equals 2 to the power of 7. And maybe I'll just explain this in a little bit more detail. If you've got 2 to the power of 3 times 2 to the power of 4, that's 2 times itself 3 times. Then we do the times 2 to the power of 4, 2 times 2 times 2 times 2. So there's my 2 to the power of 3, 2 times 2 times 2. Here is my 2 times 4. And we can say, right, how many 2's have we got multiplied together? 1, 2, 3, 4, 5, 6, 7. Okay, so that just explains how we get that, and that's why this rule applies. So that's multiplication. Division. Note that we've got the same bases. These index laws only apply when we've got the same bases. So we've got a to the n divided by a to the m. Now once again, another way of writing division is a to the n over a to the m. And just to help you remember these, if multiplication is add, well, what's the opposite of multiplication? That's division. And what's the opposite of addition? That's subtraction. So it's the top one minus the bottom one, a to the n minus m. 2 to the 8 over 2 to the 5 equals 2 to the 8 minus 5, and that's 2 to the power of 3. 3 is a power to a power. So that's a to the n. So we're going to have another letter here, so we'll put that p. A to the n, all raised to the power of p, is a to the n times p. So if you raise a power to another power, you times the indexes. So we've used some 2's here, let's use another number. So 5 to the power of 2, all raised to the power of 3. Using this rule, it's 5 to the 2 times 3, which is 5 to the power of 6. But what does this mean? That means 5 to the 2 times 5 to the 2 times 5 to the 2. Raising a power to another power. And using the first law, we know that we add those up. So that's 5 to the power of 6, which, using this rule, is 5 to the power of 2 times 3. Okay, so that's the answer. Just showing you 2 ways that you could get there. Number 4 is a fractional index. Or a fractional power. And that is that a to the 1 over n equals the nth root of a. So 9 to the power of a half is equal to the square root of 9. Now that's the radical sign. If we don't put a number there, it is assumed to be 2. So this is just asking us for what number, which when multiplied by itself gives us 9, and that will be 3. Okay, number 5 is the negative index. So a to the minus n, we need some sort of meaning for a negative power, and that's just 1 over a to the n. And the opposite applies. If you've got 1 over a to the minus n, that will be a to the positive n. So it could occur in both of those forms. So 1 over, let's go 4 to the power of negative 2 equals 1 over 4 to the 2, and that's 1 over 16. And doing the other one, if you've got 1 over 3 to the minus 3 equals 3 to the positive 3 equals 27. Number 6, and that's the 0 index. And if you have a to the 0, and we needed to come up with some explanation as to what happens when we've got anything, a is just a real number, so it could be a fraction, a decimal. What happens if we raise that to the power of 0? And that is equal to 1. A little proof of that, if you've got a to the n over a to the n, now from basic mathematics we know that anything divided by itself is equal to 1. But using the second law for division, we know that we've got to subtract these indexes. And n from n is 0, so that's a to the power of 0. So a little proof, if you like, of why anything raised to the power of 0, any real number raised to the power of 0, is equal to the number 1. So 22 on 27, all raised to the power of 0, is equal to 1. And number 7, this is advanced the fractional index rule, maybe a little bit more advanced. A to the p on q, so we'll have to also put q up here, there's also a real number, is equal to, now we know that a to the 1 on n will be the nth root of a, so a to the something on q will be the qth root of a, but we've got a to the power of p there. And we could also write it as the qth root of a all raised to the power of p. So either one of those. So how does that work? If we had 8 to the power of 2/3 is equal to the third root of 8 to the power of 2 equals the third root of 8 squared is 64. Now we say what number multiplied by itself 3 times is 64. 4 4s is 16, 4 16 is 64, so 4 is the answer. Using this one down here, we will have, it's also equal to 8 to the 1/3 all squared. Now 8 to the 1/3 is the cube root of 8. What is the cube root of 8? The cube root of 8 is 2, all raised to the power of 2, and that is also equal to 4. So these are the 7 index laws that you should be very familiar with. You should learn them, understand them, because we will be applying them not only through this course, but also through other courses. So let's just go back. An index or power is a shorthand way of writing the same number multiplied by itself many times. We have a bit of terminology here. The number that's raised is called the index or the power, 2 words, doesn't matter which one you use, and the number that is repeated in the multiplication is the base. If we've got a number before another number raised to a power, then we don't apply the power to that number, it stays out the front. We just do the powers first because of BIDMAS and then multiplied by 2. And then we've gone through each of the index laws, which I've tried to do some examples over there to show you how they work.